So good evening all of you, and today we are going to just revise the topics in the chapter number 1, that is a sets. Okay, so in the given sets, already we know that we can call the collection of such objects as a set. Okay, so it is nothing but collection of called as set. Okay, so it should be we can say that it's a days of week, or it should be then the months in a year. We can say the planets in our solar system. So we represent the set by the two methods, or we can say that generally the set is represented by the capital letters. For example, it is represented by capital letters. For example, we can write the n. N is nothing but it is a set of the natural numbers like 1, 2, 3, 4 and so on. Okay, we called as a set of natural number. Again, or we can say it's a I. I should be the -2, -1, 0. We can say that it is a set of integers. So in this way we represent the collection of that particular set. Now the methods, how to write that particular set, we have the methods also. The methods of writing sets. The first one, it should be the listing method. So in which we can write for example, set of odd numbers. Between 1 to 10. So we can write as the for example, as set A equals to, so the odd number is nothing but it should be the 3, again 7, or we can write the 5 here, and the 9. Okay, so in this way we have to write the first one, we called as an listing method. Understand? Now the next one, the next method, it's we called as a rule method. So in this method what we have to do, using the variable in general, we write the elements. The elements is nothing but inside the set, whatever the things we write there, we call as an element. For example, here general element using variable followed by a vertical line or colon. Okay, vertical line or colon, and write the property of the variable. For example, we take one example here, like a, that is a x, and x is a element of the natural number again, and which is a greater than 1 and less than the 10. Okay, here it's a, we write the set, or the, we can say this method of the writing that as an, it's a rule method or set builder method or form, and we can read, okay, read as set A, this one is the set of all x such that is a natural number. Between 1 to 10. Understand? This method we called as the rule method. So where we can write, for example, in general, what are the prime numbers? For example, the set B, it should be B containing prime number between 1 to 10. Okay, so in general we can write in this method B, okay, in the curly brace. So x there is a number between 1 to 10. Okay, so in listing method we can write this one as a is 1 to 10, that means that 2, 3, 5 and 7. Understand, these are the two types of the method. Now we'll see the types of sets. Okay, in general we have the 4 types. First one, it's a singleton set. Okay, generally in this set only one element is there. For example, okay, a set of even prime number. So you know that the even prime number is only one number, and in such a set only one element is there, we called as an singleton set. Now second one, it's a empty set, or we can say it's a null set. Okay, it should be n. in that set you can say that we can write here one example B, here curly bracket. So X is a natural number between 2 and 3. Okay, so as we know that no such a element between that's a 2 and 3. Okay, so there is no single number is there, so that's why we can say that it's a empty or null, and denoted by this symbol as well. It will be called as an phi. Then third one should be called as an, it's a finite set, as the name indicates that it containing only the just the countable or the limited numbers. Okay, for example, we take one example here. So P is a number from 1 to 22. Okay, we take divisible by 4. As we know that they are the limited, so we can write here C equals to, so 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, and 4 fives are 20, because up to the limit is given. It's a, now the fourth type is nothing but infinite set. Okay, in the given set we cannot count the numbers or the elements. Okay, the elements are uncountable. Okay, for example, we can take natural numbers, we don't know about it, just 1 2 3 4, then so on. Such numbers we called as an it's a uncountable. Okay, and we cannot count such type of the set we called as an infinite set. Now we'll see the next topic, that is a equal sets. Okay, so for example, two sets A and B are said to be equal, then okay, it's equal, then both the element of the set A and the set B should be same. For example, we take one example here. So the set A containing the X is a letter of word silent. Okay, then the set B, that means it should be the YY, is a letter of the word okay. So then we can say that if you know about this one, the A should be right this way, it should be N. As similar in the set B, you can see here it's a listen, LIS, T. So if you check both set having the elements are same, therefore we can say A equals to B. So, and now we'll see the Venn diagrams. Okay, so Venn diagram is nothing but, in the last class we discussed about it, we are the representing by using the closed figures. Okay, so closed figure should be this way, so in which we are represent our data. For example, we take the Venn diagram by using the A is equal to 1 2 3 4 and 5. These are the elements of our set, so we can write here as A 1 2 3 4 and 5. In this way we represent this data in the form of the Venn diagram. So in that particular diagram we have the one more topic, that is a subset. Okay, so subset is nothing but, for example, what we say, if, okay, if A and B are two given sets and every element of set B is also an element of set A, then B is a subset of set A. So we can written as B is a subset of A, this way. Understand? For example, we take one example here, A, set A containing 1 2 3 4 5 6 7 and 8. Okay, as similar we have the set B also, so it is 2 4 6 and 8 element. Okay, so we can represent this particular set B. Okay, first of all we make such a close figure. Okay, so okay, it should be, so this figure should be A. Okay, in the A how much elements are there? It should be 1 2 then 3, it should be 4, then 5, then 6, then 7 and then 8. Okay, now we make this, you can see here 2 4 6 8, these are the elements of the set B. Okay, so these are the elements of the set B, so that's why we can say that the set B is a subset of set A, because the set B having the element in the set A as well. So that's why we can represent this data by this symbol as a subset, or we can say that it's a element, the B's element in the set A also. Now we are going to learn about the universal. It's a universal set. So as the name indicate that all the elements, or we can say that it's a bigger set which accommodate all the given under consideration, which is general is known as a universal set. So for example, we take one example here, a cricket team. Okay, a cricket team of 15 students. Okay, 15 students selected from school, and all the students who play the cricket is a, for example here it's a team, but all students from school we considered as universal set, and we can represent this way also. First of all, the team of players, team of so it is just only the 15 members, okay, but the all students in a school who play cricket, okay, okay, so we can say that it's a universal set and we represented by U, okay. In general, the U is represented by the rectangle, understand, and inside there is a, you can write or you have to mention this, fine. Our next topic is nothing but it's a complement of the set. For example, we can take the suppose U is universal set, okay. So if B, okay, it should be the B set of the U, then all the set of the elements in U which are not in the B we called as an complement, okay. Then the set of all elements in U which are not set B is called complement of B and denoted by B dash, okay. So we can understand as an the B dash should be, so here x is the element of the un and is not elements of set B, okay. So for example, we take one example, it should be U equals to 1 2 3 4 5 6 7 8 10, okay. As similar we have the set A, okay. So it should be the 2 4 6 8 and 10, okay. Now how to calculate this A dash or the complement of the A dash? So it should be like this. First of all, what we have to do whenever we have to find out, first of all we draw one rectangle, okay. So you can see here in this set A how many elements are there, it should be the 2 4 6 10, it should be in the set A. Now the remaining one, it's a which are in the universal, okay, as we see earlier. Now these remaining elements we represented as a dash. Understand point? Therefore we can say that it should be, and the remaining are the 1 3 5 7 9. Understand this topic? Now we'll see the next topic, that is a operation on sets. Okay. Okay. First of all, the first operation, it should be the intersection of. So that is nothing but, for example, and suppose A and the B, two sets are there. Okay. The set of all common elements of A and B is called intersection. Okay, intersection of set A and B, and it should be denoted by like A, this way. Okay, should be in the downward direction. We can read as a intersection B. Okay, so we can say that A is the element of A as well as. Understand? So you can understand by one example, by taking one example. For example, here we take okay, and in the set B 2 3 6 8. Now first of all, what we have to do, we have to draw one Venn diagram. Okay, so it should be the set A having, first of all we have to check intersection is nothing but it's a common element. So here it's a 3, so we write the 3 here. Now in the set A 1 5 and 7, 3 already written here. Okay, in the set B so 2 3 here, 6 and 8. Understand? So therefore we can say that the element 3 is common in set A and set B. So we can say that therefore A is nothing but A intersection B equals to, here it's a one element is common. Understand? This topic we called as an intersection. Now we'll see the union of two sets. So as we know that, so let consider that let A and B two given sets. Okay, so then the set of all elements of set A and set B is called union of two sets. And it is written as A union B. Okay, and read as a union B. Understand? For example, we see one example here. It should be the A equals to here it's a -1, then -3, -5 and the 0. Okay, so in the B it's 0, 3 and 5. So we can see here, okay, by the Venn diagram, when we draw the Venn diagram, it should be the -3, here it's a -5, then -1, here it's we write the 0. Now we have this set B also, here it's a 0, 3 and 5. Okay, so we have the different the two sets having the common element 0. Now what is the union? Union is nothing but when we A union B we said, so that time what we have to do, we have to all those elements in a single set. It should be like it's a -3, -5, then 0, -1. Understand? Note that A union B, or both are the same, B union A, because all the terms in the set A and set B we can write this way. Understand everyone? All of you? That is very important topic. We can say that it's a number of the elements. Okay, number of elements in set, the given set. Okay, whatever the set we have given. For example, we take the let set A, okay, equals to it's a 3, 6, 9, 12, 15. Okay, these are the numbers in the table is given set with 5 elements. Okay, fine. As similar, the number of the elements in set A is denoted by or by n of A equals to how much elements? It's a 5. Understand? For example, we take the next one. Let B is a set having it's a 6, 12, okay, so count the how many number, 1, 2, 3, 4, 5, 6. So we can write this way, n B, it should be equals to how much? 1, 2, 3, 4, 5 and 6. So we write this way. Understand everyone? Okay, so what we have to do, we have to find out the number of the elements in the union and the intersection. Okay, number of elements in union and of sets. Okay, we have the union as we know that, and the intersection as well. Okay, so for example, we follow this same set. Okay, set A and the set B. Fine. So first of all, if you want to calculate n of A plus n of B equals to 5 plus 6, it should be 11. We taken as a 1, as that means. So tell me A, it's a union B, so we can write these numbers. So 3, 6, 9, 12, 15, like this. 3, 15. Then again we have the, it should be, so we never write the numbers again and again. Okay, as we study in the previous class, 5, 6, 9, 12, 15. Okay, so already 6 there, so we do not write again. Understand? So now, so tell me number of A union B. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9. We write this way. We are given as a second equation. Now to find out the particular, now what we have to do, we know that to find the it should be that particular, the intersection. If you want to find out the intersection, understand, intersection, to find A intersection B, that means how many in the A and B, you can see here only 2 elements are common, that's a 6 and 12. Understand? So we can say that n of A intersection B equals to how much? 1 and 2. So we write here as equation 3. Understand? So now what we have to do, for example, n of A plus n of B, we can write this way. A union is the intersection of B. Okay, so we can write here it's a 5 plus 6 minus 2. Okay, so we got the answer, it should be the 9. So therefore n A union of B equals to also 9. Understand? So therefore we can say that n A union of B equals to n A plus n B and minus n A intersection of B. Understand? So we can verify as well. So n of A how much? It should be 5, and n of B how much? It should be 6, as we know that. Again n A union of B how much? 5 plus 6, it should be the 11, and n A intersection of B how much? It should be 2. It should be 2. So we got this formula as an n a union of b equals to n of a plus n of b minus n a intersection b. So union formula is 11 equals to, so in this way you can understand this.